know the definition of implicit? Implicit.
It's implicit.
That's one thing.
It's implied. Is to be implied, though not directly expressed. So that's word from the Webster's Dictionary. And it's the same in math. If we're going to do, like the title says, implicit differentiation, we're going to do it in an indirect way. Okay? So the problem is all of our equation up to this point has been y equals blah, 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 x, blah, 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 whatever. So it's pretty easy to do direct differentiation, meaning dy dx with respect to x. The problem is when we have something like this, x squared plus y squared equals 25, it's not in the form y equals. So how could we find the equation of the tangent line? And just for fun, does anybody know how to graph x squared plus y squared equals 25? It is a circle. It's very close to the unit circle, where it's x squared plus y squared equals 1. So what's the difference now? It's 5. The radius is 5, actually. So the center is at 0, 0, and we're going 5 to the right. 1, 2, 3, 4, 5. 5 up for the radius. 1, 2, 3, 4, 5. 5 to the left. 1, 2, 3, 4, 5. And down 1, 2, 3, 4, 5. And we're making a nice circle. I think I'm going to actually use my circle drawing tool because I can. Woo! Yeah, I'm just trying to make my circle a little bit nicer. Yeah, don't make it look like a football or anything like that, because then it's not going to work too good. Okay, so there's my nice circle. It's finally kind of nice. So then, how do I draw? Actually, I shouldn't be too impressed. I actually have it a center 0, 0 and radius 5 right here. So, woo. Okay. How would we find the equation of the tangent line going through 3, 4? Notice that 3, 4, 1, 2, 3, 4, it actually goes through that point right there. How am I going to find the equation of the tangent line that's going right through there? Graphically, it would be easy to find the equation of the tangent line, right? Yes? How could I find graphically the equation of that tangent line? Huh? Yeah, it helps if you have a ruler. And the other thing is I know it's going through 3, 4, so I'm trying to make it through that it is exactly there. So, but normally you wouldn't necessarily know it's going through 3, 4, except that I'm telling you that. So, can anybody tell me the equation of this tangent line? You're telling me you forgot your grade 10 math here. A slope of -1?
Oh, yeah, look at that.
Is it? It looks like it, but I doubt that that's actually the case. It's just but the problem with my line is like Kyle is saying, how do you know exactly where it hits? So I know I'm kind of making it. My point is pretty big. So now if I look like that, you could say, oh, that's not really, like, kind of looks like, what's the slope? So we got to have a better way. The better way is algebra, right? And using calculus. So how could we do that? Well, we need to have it in the form y equals. So when you have x squared plus y squared equals 25, how do I solve for y? Move x over. So y squared equals 25 subtract x squared. Then what? we square root it, and we don't just get the square root of 25 minus x squared. We get plus or minus. So just so you know, and if you think about this for a second, do you remember how to graph something like this? From grade 12 math, we would graph this parabola, which is an upside down parabola that is 25 high. And then we would square root all the y values, yes? So the height of 25 becomes a height of 5, right? And then you have, yeah, so, but we already knew what it's going to look like from the circle. And the reason why we have plus or minus is because then we have the reflection of the same graph that got square rooted. Anyways, so we need to find the derivative of this. So let's just, because the line is going through the first quadrant, do we really need to have the minus part of it? The minus part of it is this part right here. So we can actually we don't need negative square root as it is in Q1. So we are going to find the derivative of y equals a square root of 25 minus x squared. And everybody knows how to do that because we know the chain rule. So I'm just going to write it again over here. The first thing I'm going to write is bracket 25 minus x squared to the power of half. That's the same thing. Yeah. Okay, so what would the derivative be then? 1/2 25 minus x squared to the power negative 1/2. Are we done? Times. Not 25. Negative 2x. Does everybody see times negative 2x? Yes? And we could simplify that a little bit. The 1/2 times the negative 2x gives me negative x on top, and then the square root that's negative is now on the bottom, yes? Okay. Yeah. Sorry, y prime equals that. Very good. So now that just gave me the derivative, but I need to know what to find the equation of the tangent line. The actual slope. So I'm going to turn this into slope. Yes? And how do I find the slope? I plug in the 0.34, but I don't need the 4. So it's going to be negative 3 over the square root of 25 minus 9. 25 minus 9 is 16, so I get negative 3 over 4 as my slope. Now, did that look like a negative 3 over 4 slope? Down 3, 1, 2, 3 over 4, 1, 2, 3, 4. Yeah, it does. It depends. That's the problem is with the tangent line, you have to be able to get it exactly right when you're drawing it. Okay, so I have the slope. So what's my equation of my tangent line? Y minus 4 equals negative 3x minus 3. And I could leave it like that. Yes? Okay, so I've done this not implicitly but explicitly because I actually solved for y and then I found the derivative. So the next method is what we're learning today, is the alternative method, which is implicit differentiation. So not all equations can be solved for y, and I'll tell you that right now. There'll be y's all over the place, and that's when you're going to know that you have to do implicit differentiation. So what you're going to do is you're going to impose a d dx, or the derivative with respect to x, to both sides. So do you see you have x squared plus y squared equals 25. So what I'm doing is I am going to d dx both sides. D dx that, and d dx that side. It's kind of like Algebra 101. Whatever I do to one side, I do the other. So I'm finding the derivative with respect to x on the left, so I got to do that on the right. So normally when I had a y there, it would be dy dx. But that's what I was solving for anyways, was y prime, right? I'll repeat what I just said there. When I find the derivative here, when I have this, does everybody see I'm doing d dx, and I end up getting dy dx, which is y prime. But on this side, when I find it, I have to use a chain rule. But again, I'm finding it with respect to x. So we're going to differentiate individually. Since you're differentiating with respect to x, you must multiply by dy over dy and rearrange to differentiate y. Okay, so I'll explain what I mean here. So I'm going to differentiate individually. So I'm going to write this. So dx squared over dx plus dy squared over dx equals d25 over dx. So all I did was I differentiated them all individually, and that's a legit move of differentiating, right? Okay, so the thing here is I can find the derivative of x squared with respect to x. That's pretty easy. What do I get? I get a 2x. And I can find the derivative of 25 with respect to x. That's pretty easy. What is that? It's 0. The problem here is I can't find the derivative of y squared with respect to x because there is no x's in there. Do you see what I'm saying? So the trick here is to essentially put a form of 1 in there, which is dy over dy. So that's what I'm going to do. I'm going to do it in a different color. And I'm going to put dy over, I'm not going to have enough room here, so I'm just going to scooch this over here a little bit. So plus d, I'm going to put y squared over dx, and then I'm going to times it by dy over dy. Sorry if you didn't have enough room there, but dy over dy would cancel, but I don't want it to cancel right now because the purpose of the dy over dy is to get that I can actually find the derivative with respect to y. So what I'm going to do right now, instead of canceling this, is I am going to rearrange this, because the nice property about multiplication of fractions, essentially you can look at this as fractions, is, you know, if this was 2 over 3 times 3 over 4, I could rearrange these two and put it as 3 over 3 times 2 over 4, and that would be a legit move, right? So same with over here, is I can put this y here and this dx here, and that's what I'm going to do right now. So I'm going to write it as dy squared over dy times dy over dx. So all I did is I did a switcheroo right there. Okay? Everything's legit still. Yes? Okay, so what is this equal to? Dy over dx. It's equal to y prime, yes? Yes. What's the derivative of y squared with respect to y? It would be 2y. So this now becomes 2x plus 2y, y prime equals 0. I'm just going to get rid of this fractions mess here.
So we solve for y.
So now we're going to solve for y prime. So how would we solve for y prime? So solve for y prime. Y prime's right here. So I got to move the 2x over. So I get 2y, y prime equals minus 2x. Yes? Then how do I get y prime by itself? Divide. So I get y prime equals minus 2x divided by 2y. Everybody agree? And you can simplify that. Yes? So I get y prime equals minus x over y. And you might say, well, wait a second there. That's not the same thing we got. It is actually the same thing we got. What does y actually stand for?
Oh, 3 over 4.
No. Good try, though. Y stood for the square root of 25 minus x squared. So do you see when we got this? we actually have the same thing. It's just I'm not writing it as the y. I could say or minus x over the square root of 25 minus x squared. You see what I'm saying? It's the same thing.
Do we have to do find when we have to find both of them?
No. What do you mean both of them?
Should we have
No, this is an acceptable answer. Yeah. So guess what? Our points, the point was 3, 4, yes?
Yeah.
What happens when I sub 3, 4 into there?
the slope?
I get the slope of negative 3 over 4. I don't actually have to have this. The 3, 4 will actually calculate my slope. M equals negative 3 over 4, and then I go about my business. It's all good. Okay. So the key here is implicit differentiation is used when the y's are all over the place. Like for instance, would I use implicit differentiation here? Yes. Does everybody see yes? Would I use implicit differentiation here? No. Would I do implicit differentiation here? No, I would just move the 3x over. It's y equals negative 3x plus 5. It's pretty easy to solve for, sorry, that's supposed to be next. So does everybody see, it's when it's really hard to solve for y, right? In one move, I can move this 3x over the other side. It's pretty easy, right? Okay. Does everybody agree in this? This is implicit differentiation. Okay. I want to go back to the previous one where I did implicit differentiation. So do you see how I ddx'd both sides and then I threw in this? And then that's where people are going, whoa, 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 whoa. Okay, so I showed you this because I want you to see why, in fact, I get y prime. But does everybody see I could go directly from this step to this step if you know exactly what to do. Watch this. What's the derivative of x squared? 2x. What's the derivative of y squared? 2y with an extra y prime.
Why is it extra y?
Because of the fact I had to do this to manipulate with respect. No, that's why I showed you this. I didn't just throw that in there. I did a form of 1. Then I did the rearrangement so I could actually find the derivative with respect to y.
If you were to get this question, you'd like to skip all that, you add the y prime.
Exactly. So then the derivative of 25 is 0. So knowing that little shortcut, yes, because you're always finding the derivative. Look at this. The derivative of y with respect to x. That's the y prime. So you're always finding it with respect to x, so you have to have that additional y prime in there. Okay, so now the problem with this, does anybody see a problem here? What? You have to use the product rule. Yes. I probably should have started with that easier one to start with. So I would put the 4x squared with that and this as the second one, right? This is another one. I would have that. And then these are all separate, so it's all good to go. Okay, so we're going to do the product rule for 4x squared y cubed. So the product rule says find the derivative of the first. So what's the derivative of the first? 8x, leave the second one alone. Does everybody see? Beautiful. Plus, leave the first one alone. Find the derivative of the second. So what's the derivative of the second when we're doing implicit differentiation? 3y squared times y prime. Yes. Okay. Do the next one. Do the next one. What's the derivative of minus 3x? Minus 3. Leave the second one alone. Yes? Plus, but it's a minus 3x, so I'm going to put plus a minus 3x, so it's just minus 3x. What's the derivative of y? 1 with a y prime. So I'm not going to write 1 y prime. I'm just going to write y prime. Equals. Is everybody good with that one?
Yeah.
Oh, no. Yeah.
Okay. Derivative of minus 3x is minus 3 with the y left alone. Then I leave the first one alone and find the derivative of the second. The derivative of the second is 1, and then you have to have the additional y prime. So I'm not going to put 1 y prime, I'm just going to put y prime. Okay, what's the derivative of 5x? What's the derivative of 2y?
Y times y prime. What?
Sorry, say it again.
2 times y prime?
2 times y prime. Very good. Okay, I thought you said 2y y prime.
No.
Okay. We're not done here, people. We need to, did you see it says find dy dx, which means you need to solve for y prime. So that means, and you guys did this with, I know, the trig identities, where you had this big crazy thing and then you put everything over to one side that had, I think it was trig identities, I'm thinking of a different unit, but anyways, where you had to have, so let's get everything that has a y prime on the left side, move everything else onto the right side. So just for fun, I will highlight the y primes just so I can see it a little bit better. So I need to have 3 y primes over on the left side. So I'm going to write this 4x, actually I'm going to multiply the 4 times 3. Does everybody agree I can do that? Okay, so 12x squared y prime minus 3xy prime minus 2y prime equals. Does everybody see what I did? I moved all the y primes over to the left side. And if it was there, I just left it there. Now I'm going to move the other stuff over. So I'm going to go 5. Yes? This has to go over. So minus 8xy cubed. And then this has to go over. So plus 3y. This is a cube, by the way.
Oh.
Okay. So now what do I do? You factor out the y prime. Very good. And when you're really good at this, you won't even do this step because this takes too long to write. Yes? Does everybody know what I'm saying? What unit was this where we had to factor it out?
And divide.
And then divide.
That was for logarithms. We had to do that.
Oh, it was for logarithms. For sure it was logarithms, where we had to factor the x out and solve for x. That's right. And most people would just skip the step where they factored out because they know that everything gets divided except the one that's there. So y prime equals 5 minus 8xy cubed plus 3y, all divided by 12x squared y squared minus 3x minus 2. So there's my answer. What do you think? Huh?
Is this the harder unit? One of the harder units?
No.
It just gets all harder from now. Okay. Okay, does everybody see the next one? Does everybody see we have a product here? Is this a product? What's this? It's a chain, you guys. It's not a product. It's cos of this whole thing here, right?
Thanks a lot.
It's a chain. So do you want to get started on this? So watch. The derivative of y is y prime. Or you can write dy dx. It's up to you. Now technically, you guys, it's said here to find dy dx. So technically you're supposed to say dy dx equals. However, this is probably, again, on a multiple choice. But actually, a lot of the times, the implicit differentiation, they ask you for the slope at a certain point. So you have to do all this, and you get no credit for it. Okay, product rule. The derivative of y is 1y prime sine x left alone, right? Plus y left alone. What's the derivative of sine x? Cos x. What's the derivative of x squared? 2x. This one's a hard one. I stumped a few people on this one. This is a chain rule. So you need to find the derivative of cos with the inside left alone. So that's minus sine y squared times the derivative of the inside, which is 2y prime. Yes? So I'm just going to circle my y prime so I know what I'm solving for. Yes? So move this over. I get y prime sine x plus sine y squared. Oh, I need to make this a little nicer. So I'm going to do 2y prime sine y squared equals minus 2x minus y cos x. So then y prime is going to be minus 2x minus y cos x divided by sine x plus 2y sine y squared. There you go. Very good. Did anybody get this? It feels good when you can do something this difficult and get it right, hey? Yeah. Okay, so this time you have to find the slope. So I'll give you the answer of the slope because you could do everything all the way correct and then the last step get it wrong. So the slope you should get is negative 3 over 10. So I'll give you a second to figure that all out. Okay, does everybody see? This is a product rule there, right? So the derivative of x squared would be 2x with the y left alone. Then you leave the x squared alone and you find the derivative of y, which would be 1 and then y prime. So I'm just going to put y prime. Then the derivative of x is 1. I'm not going to write the 1. So then I just have the y cubed left alone. Plus, then the x left alone. And here's where a few people made a mistake. They forgot there's a y prime. When I find the derivative of y cubed, it's going to be 3y squared y prime. Because the only way I can find the derivative of y is if I have that extra dy dy, right? So that's how I get the y prime, because I remember that first example, I moved the dx and the dy around to get that. So anyways, the derivative of minus 2x is minus 2, and the derivative of 2, some people made a mistake here, it's 0, right? Equals 0. So I'm going to get my y primes all by itself. So x squared y prime plus 3xy squared y prime equals 2. I move that over, minus y cubed minus 2xy. Sometimes I actually count how many terms I have to make sure I have them all still. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do you see? Because you can really lose something in this big long string, right? So then y prime would be 2 minus y cubed minus 2xy over x squared plus 3xy squared. So then my slope is going to be 2 minus 1 cubed minus 2 times 1 over 2 squared plus 3 times 2 times 1 squared. So then I get 2 minus 1 is 1. 1 minus 4 is negative 3 on top. 4 plus 6 is 10 on the bottom. Okay. Everybody did that. I want to show you a time saver. If this is a multiple choice, they're not going to have any of this in here. Does everybody see? They're only going to have the slopes left. So I'll show you the time saver. At this point here, after I found this, does everybody see? I could have plugged the x and the y right in there instead of solving for y prime first. It might have been easier. So let's just see. If I put a 2 in there, I get 4y prime. If I put a 2 and a 1 in there, I get 6y prime equals 2 minus 1. And the x is 2, so then I get minus 4. So essentially I get 10y prime equals negative 3. So y prime equals negative 3 over 10. However, because this is technically, I subbed it in, these are all m's now, right? So do you see when you're doing multiple choice, I don't know, was that faster than doing all that? It might have been, right? But if you're solving for y prime, then you have to do this step, right? Okay, so does everybody have a chance to do the last example?
Yeah.
Oh, okay. Let's see if we're right then. Again, this is a product, right? This one might be the easiest of all of them. 5y to the power 4y prime plus 6x y squared plus 3x squared times 2y prime plus 20x to the power 3 equals 0. Yes?
Yes.
Okay, so then 5y to the power 4y prime. I'm going to simplify this a little bit. So plus 6x squared y prime equals minus 20x cubed minus 6xy squared. I'm going to count to make sure I have enough terms. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So then y prime equals minus 20x cubed minus 6xy squared all over 5y to the power 4 plus 6x squared y. Is that what you got? Maybe a different order, but whatever, yeah?